Now, this is, of course, the formal math part of it. The difference on tan and cotan, of course, is the period. Remember, for sine and cosine, it's 2 pi over b. So if you look at secant and cosecant, they're also 2 pi. That's going to be the same, sine, cos. Anything for sine and cos is also true for secant and cosecant. Tan is where it gets different. Tan switched to b, or pi over b, a single pi over b. So when I click the slide here, and obviously it's pretty blank because we're going to add in a lot of information for tan, and by a lot I mean really a couple things here, because we really only need 2 pieces of the puzzle to get these drawn. One is the period. Let's start with that. And I didn't wear my tall enough shoes to reach the total top. Let's work with it. Single pi over b. And of course, b is the same location as it is for sine and cosine. B is the coefficient on x on all trig functions, so that comes from the same spot. Now, the other piece that you have to find to draw these graphs are the vertical asymptotes. I love the response to vertical asymptotes. Now, I'm going to talk about the why there's vertical asymptotes, and then of course we need to kind of talk about some easy ways to memorize them. Here's why there are vertical asymptotes. Tangent, believe it or not, is really considered a rational function. Rational is a fancy name for fraction because, of course, we know our identities. You can define tangent by sine over cos. So it's really fraction in disguise. Now, we have vertical asymptotes anytime our denominator is 0. You can't divide by 0. 0 under the line's undefined. We did that in previous chapters. It's the same thing. So to find my vertical asymptotes, I'm kind of zeroed in, or I'm thinking about, okay, when is cosine 0? 0 under the line undefined. So I'm thinking about, well, I couldn't draw a triangle, because, I mean, adjacent, hypotenuse, how are you going to get 0? You can't have a side length on a triangle to be 0. So now I'm back to thinking from last semester about those quadrantal angles, aka the points. Or as you like to call it, the wheel on your unit circle. Okay, I'm not drawing the whole circle. Nobody wants to watch that. We're looking at the points. And I'm kind of going through detail on tangent because it's going to kind of overlap into cotan, secant, cosecant too. Now I'm looking at where cos is 0. Cosine, remember, is our first coordinate, our x coordinate. So I see cos is 0 at the top point and the bottom. Now we're in radians, of course. So the top point, we know 90 degrees, pi over 2 in radians. Now to make our life easy, I'm all about making our life easy. We know this is usually, we talk about it being 270 degrees, 3 pi over 2. I don't even want to write that. That seems like too much work. I'm going to use a coterminal angle. You could rotate clockwise or down and think of that as negative 90 degrees, negative pi over 2. So when I go to find my asymptotes, I'm going to take that whole expression with x, that whole bx minus c. Maybe there's a minus c, maybe not. I don't know. We'll see what we got. And I'm going to set that equal to positive 90 over 2 and negative 90. So the two things we're going to find to draw tangent, period, that's easy. And then to do our asymptotes, we're going to, of course, set it equal to plus or minus pi over 2. Now, why I got carried away and did so much detail on this one, is think about this. It's all going to flip for cotan. Cotan's going to flip. Sine's going to be on the bottom. Sine is 0 at the left and right point. So cotan, we're going to use 0 and pi. So I'm always like, oh, how do you remember all this? Okay, so here's how I remember it. Tangent, tangent. I think top and bottom. Plus 90, negative 90. Then cotan is the left and right. Tan, top and bottom. Cotan, left and right. That's how I remember it for my asymptotes. And it's going to work on secant, cosecant, all of that when we get to it. All right, so our basic period function of tan. Here comes my great drawing skills. Period single pi over b. Of course, our b is that coefficient on x, which is just a 1. Not even worth writing. Now, this time, of course, all we have is x. There's no phase shift. There's no exciting coefficient on x. So I'm just going to set it equal to plus or minus pi over 2. Okay. So remember, those are our vertical lines. We're going to get close to. We're not going to cross or touch. I'm going to click this back one slide here, just add one more thing when we get to the drawing, but let's start with this. So again, I'm going to ballpark negative pi over 2. That looks good. Positive pi over 2. Got it. And I'm going to draw 2 dashed vertical lines through there. Missed kind of a dash. Okay. Next thing we're going to do, easy thing, you're going to find what's exactly in the middle of your 2 vertical asymptotes, the midpoint, which would be right there at 0, 0. Now, before I draw this curve, I'm going to click it back a slide, because I'm going to add one more thing on this, okay? One more detail to draw our curves. Now, to draw the curve, of course, common sense, you look at your lead coefficient. On our graph, it's 1, A is 1. So just like slope, my curve is going to rise to the right. So I'm going to add one little note here. If A is positive, rises right. And you can probably figure out, you know, for dramatic emphasis, I'm going to throw on here if A is negative, it's going to rise to the left. It'll be reversed. So again, I just look at the lead coefficient and follow it. Give me a second to jot that in. Now again, just prepping us for what's coming at us. Cotangent, of course, everything is, it's like similar but reversed. Everything is reversed. So on cotangent, if A is positive, it rises left. If A is negative, it rises right. When you get to cotangent, everything is kind of switched around. So when I draw this, let's click it here. So I'm going to take my midpoint. The rest of my drawing skill. It's a curve, it rises to the right because A is positive, and then this half falls left. So that is 1 period of tan. Now, fun news, exciting news, as always, we need 2 full periods. So, okay, all right, doesn't matter if we go right or left. I'm going to go right because I feel like I have room on the right. I don't know. So I'm going to take my width here and just kind of copy it over. Kind of mark it. I'm going to copy that whole thing. So of course I need to label this. So we got to do a little mental math here. We left off at pi over 2. And remember, I'm adding a period. Our period was pi. Well, that's not too bad. Half plus 1, 1.5. Because we need to label that. And again, between a half and 1.5, you're covering 1 pi. From negative a half to positive a half, 1 pi. Same thing, I'm going to find the midpoint. What's directly between 1/2 pi and 1.5 pi? Pi. And I'm going to repeat that same red curve. So that is what tan looks like. Okay? Easiest ones to draw. They don't take as much work, that's why I like them. So let's do some with some other numbers, of course, here on it, just for funzo, right? So period, of course, pi, single pi over b. Now our b, of course, that coefficient on x is that 1/3. So when I simplify that, we're going to have 3 pi. Got it. And remember, that's how often the graph repeats. 0 to 3 pi will look the same, 3 to 6, so on and so on. All right, vertical asymptotes. We take whatever's with x over 3. And I have to remember tangent, top and bottom points. So positive pi over 2, negative pi over 2. The only thing that's different from the last one, I gotta do a little algebra here to solve for x. I need to get rid of this over 3 situation. So I'm gonna put my vertical asymptotes are plus or minus 3 pi over 2. Which makes sense to me. Negative 1.5 to positive 1.5, we're going to cover 3. Elliot, hang on, let me get it drawn, then I'll answer your question, okay? Now, our parent function, the asymptotes are 1/2 pi. It should be wider. Is it going to be wider? I don't know. We'll try. So I tried to make it a little wider than the last one. Again, I'm not going to be totally nitpicky about it, since we are sketching these. Okay, now, next question. find the midpoint, easy. Watch your lead coefficient, it's negative, so it should rise to the left, it's gonna be reversed. Okay, here we go. What's the 4 do? The 4 represents a vertical stretch. Good, Owen. Now I'm like, oh my God, how am I gonna show this vertical stretch? So this is why I said, let's just, take a look at the old graphing calculator, okay? So I'm in radian modes. I put the original just as tan x just to show you our parent function, and then I could have put negative, but who cares? I just made the next one 4 just to show you the difference. So the parent's gonna be blue, the 4 tan is gonna be red. With my lack of artistic skills, am I gonna be able to accurately show you the stretch of 4 and make the red? I'm going to try to kind of make it a little more stretched than the last one, but no promises, okay? We're sketching these by hand, just do the best you can. So recognize, here we go, it should be, oh Lord, I can't guarantee that that's stretched more than the last one, but I'm going to try, okay? Very hard to show, I'm not going to get in a twist about it. I am going to do one more period, but I'm going to answer Elliot's question. Do you remember Elliot? I rambled on so long.
Yeah. I wasn't here when you explained how to find the vertical asymptote.
Well, hang on. You know what? Just for the sake of time, I can help you with that at the end, okay?
Okay.
So I'm going to try to repeat the same thing. I might have to extend my x-axis a little bit here. I'm going to do my second period on the right-hand side. Let me just extend that a little bit. Copy it over. Okay. Now I need to label this. We left off at 3 pi over 2, and I'm adding our full period. So we do have to do a little fraction work. 1.5 plus 3, 4.5. I'm going to go 9 pi over 2. Takes up less room. Got it. And in the middle, what's directly between 3 pi over 2 and 9 pi over 2?
No, just kidding.
What did we come up with? I think I heard 6, which you're on the right track. 6 pi over 2, 6 over 2. And I'm going to try to draw that same stretch. I know it's not going to be great. I'm going to try. Okay. So any question? Again, I'm not going to be like, oh my gosh, it's not vertically stretched by 4. I'm not going to freak out. Just try, since we're sketching it. Okay, last one. Now, this one of tangent, I should say that's for the tangent. This one technically has a phase shift, but it's easier, I think, to do the phase shifts on these than it is sine and cosine, because it's going to fall out on your asymptotes. So here we go, period. Pi over b, b is still the coefficient on x, pi over 1, that's easy. Now, the vertical asymptotes, I take whatever is with x, and I set that equal, remember tangent, top and bottom, plus or minus 90, plus or minus pi over 2. Now, of course, I have to do a little work here and solve for x. The nice thing is, when you solve this for x, that will adjust for the phase shift. You don't even have to think about it. Okay. Little fraction work. I'm going to do positive 1/2 plus a quarter. What's a half plus a quarter? 3/4. What is negative 1/2 plus a quarter? Negative 1/2 plus a quarter. Negative. How's our fraction work here? Negative 1/4, 1/4. I'm getting scared. You can use your calculator if you really had to. Okay, so that's going to adjust for the phase shift. We don't have to do anything else but draw. Okay, so negative 1/4. Got it. Now, 3/4, of course, should be further to the right from 0 than our quarter on the left is. So I'm gonna try make it look decent. Got it. I'm gonna mark the point in the middle. All right, how are we doing? Now, fraction work. You need that middle point.
It's like, I don't
Wait, you're going the other way.
Well, can we first label this?
Oh my
Elliot.
God.
Hang on, guys, I can't hear. Elliot.
Pi.
What do we have for what's exactly in the middle?
Pi.
Pi over.
Pi over 8.
Are you making up numbers?
Yes.
Can we get a real specific answer here? Okay. Do I need to? Do we have to have a fraction talk here?
Wait. Yes, I do. It's. Is it one? No, it's not. Dude, it's an 8. It's an 8. It's an 8.
It's a 4. It's a 4.
Wait, no, it's not. It's a 4. It is a 4.
Are we?
It's pi over 4.
Are we confident with our answer?
Yeah.
Okay, I'm scared. That is right. Now, okay, just hold on, people. We have a lot of graphs to get through. Focus here, focus. Now, oh my lord. 1. Focus. We still have three more graphs we have to do.
Oh, I get it. It's not
So remember, you should be equidistant between your vertical asymptotes. Easy way to check it. Curves, which way are they rising, left or right?
Right.
Right. There's no stretch, so there we go. I don't know why, just out of habit, I always do my second period to the right. I don't know. Habit. 3/4 we left off at, 3/4 pi, and we're adding a period. So 3/4 plus 1, 7/4. No one agrees, so I must be right. Okay, this should be easy. What's in the middle of 3/4 and 7/4? 5/4. Okay. Whew. Got it. All right, so everything you know about tan is kind of similar for cotan, but we have to switch a couple things. So listen, to save us some writing, here's the thing for cotan. Obviously the curves are going to work opposite. If A is positive, they rise left. Negative, they rise right. What's also going to change, your period will be the same, are the asymptotes. Because now for cotan, you'll have sine on the bottom. Sine is 0 on the left and right point. So it's going to shift on the asymptotes for us. So for cotan, of course, I'm going to put the period down. It's pi over b. Put the easy, obvious stuff. Okay. Let's also put how the curves work. If A is positive, I'm just going to use the symbol, rises left. And obviously if A is negative, rises right. Okay. Now, what also is going to change on this are the asymptotes to it. They are vertical asymptotes, just again, because this is really a fraction in disguise. Cotan, of course, is cosine over sine. We know our identities, right? We know our identities. And of course, we have asymptotes when the denominator equals 0. And remember, sine is 0 on the left and right points on your unit circle. So when I do the vertical asymptotes for cotan, I take whatever's with x, there might be a phase shift, there might not be, and I set it equal to 0, 0 degrees, 0 radians, 180 degrees or pi, of course. So 0 comma pi. So these are kind of the two big things we need. Okay. And we're going to see asymptotes on secant and cosecant too. Those are also really fractions. I'm going to show you a cheat on that one, though, Avery, so get ready for that.
This is so upsetting.
All right, so let's draw cotan. So our basic parent function, period is the same as tan, pi over b, b is 1. Now no phase shifts, no weirdo numbers with x. I think cotan left and right points, 0 and pi. And the curves work opposite. What we think for tan. All right. So first vertical asymptote at 0, which of course is kind of hard to draw the one at 0 because you're on the axis. And then pi. Just like you did tan. Figure out the midpoint. What's between 0 and pi? Half, yep. Now careful here. Which way are the curves going to rise for a positive 1 lead coefficient? Left. Okay. So that is our one period of the parent function cotangent. Now I need the second period. This time, I think it's probably easier just to go on the left because I can just subtract to pi over there, negative pi. You could go to the right, I don't care of it. Okay. So negative pi over 2, and then I'm going to draw that same red curve. Got it. So tan and cotan, pretty simple. Any questions on that one? Okay, let's do one more cotan, then get into secant and cosecant. All right, I don't know why, like it didn't display very well. Can you catch that that's a little baby negative in the front? It's negative 1/4. I hope that kind of showed. I know, it's like the world's tiniest negative. It wouldn't let me enlarge it. Okay. Here we go, people. Quiet, paying attention. We've got a lot still to get through. Okay, period. Single pi over b. Well, our b is 1, so it's fine. Now, asymptote. Yes, I know there's a phase shift, but when we calculate them, it's going to fall into place with our phase shift. I'm going to take whatever's with x. Now, cotan, left and right. So 0 and pi. Okay, I'm going to solve for x. So we have to make two calculations. 0 minus pi. That's easy, I got it. And what's pi minus pi? 0. So that's going to move it to the left. There's a hard copy of the homework over there, so if you want. I'm scared. All right, negative pi. Here we go. And 0. Okay, middle point. Now, careful. When you draw your curves, remember that's a tiny negative. They should rise which way? To the right, to the right. And the 1/4, I should have a vertical shrink. I mean, I can't show that. I'm going to try. That's really not showing it very well. Okay. All right, let's do our next period. I'm going to do it to the right-hand side, so I'm going to add pi over. And positive a half.
Like knowing my rights and left.
I don't know what to say to him. I don't know. Okay. So there's
that's
tan and cotan.
When I'm driving, you can't just tell me like left turn. You gotta be like go that way.
Oh,
I don't know what
Gail, I don't know. All right. Any questions, tan or cotan, that I can answer before we get into the last two?
Do you feel bad tonight?
A little bit.
Look, we're twinning today.
Okay. Cosecant. Now, here we go. A little more details on cosecant. Focus, people. One. Which Trig's function does cosecant relate to? Sine or cosine? Sine. So I'm going to start cosecant. I'm going to start by drawing the sine curve. I kind of think of that as like my template, and then I'm going to transform it into cosecant. So you can see it's very blank over there because I'm going to write down everything that is true for sine. To graph sine, we needed the amplitude. We needed the period. We needed the increment. So think about, I'm just going to put sine in parentheses here. We need the amplitude. Absolute value of A. We need the period. 2 pi over B. We needed the increments. Period over, do you remember? 4. Now, there could, of course, be a phase shift and all of that sort of good, fun-filled stuff. Let's add on the phase shift just for fun, because we're going to need that. You set whatever's with x to 0. And, of course, solve it. Now, so, of course, how is this different? I mean, it's going to be a little different, obviously. It really takes us one extra step to kind of transform it to cosecant. So again, we're going to talk about those vertical asymptotes because it's really a fraction. Vertical asymptotes happen whenever the denominator is 0. So once again, I'm thinking about when sine is 0 on the left and the right. So 0 and pi. But I'll be honest, I don't even remember all of this good stuff for this one. I can just draw it off the sine curve. And of course, there's going to be more than just those two vertical asymptotes because it's periodic. It's going to be repeating. They'll keep going on. But that will just get us for the first period. But again, I don't even get in a twist about that. I can show you how you can do it all off the graph. So first thing I'm going to do here for our parent function of cosecant, I'm going to, in green, because I picked up green, think about sine right now. If I just swap out cosecant, and I'm going to draw the sine curve over there. Okay, a little more detailed than what's on the board, but obviously. Amplitude 1, period 2 pi over b, increments period over 4, 2 pi over 4. There's no phase shift, there's no center line shift. Let's do it. So I'm going to start by drawing the hill and valley for sine. So of course, amplitude 1. 4 increments for 1 full period. And we're scaling by half pi. Half plus a half, plus a half, plus a half. Now, don't draw on like a bold sine curve. I'm going to draw it dashed because it's really not my answer. It's getting me to the answer. Now, positive 1, so we're going to have a hill and a valley. And I have some kids that will just do it, those points, they can see the hill and valley. But obviously for our first one, I'm going to kind of dash it on so you can see them a little better. So that is sine. Okay, cosecant, I'm actually going to draw that then in red. Now, cosecant, of course, I'm like, oh, it's a fraction. There's vertical asymptotes. It's 1 over sine, and sine equals 0, 0 and pi. Okay, too much work already. I feel bored with it. But 0 and pi. Pretty much what happens. Pretty much, here's my very technical math description. Get ready for it. Basically, what's going to happen, you're going to draw these vertical asymptotes. Like I said, the first ones would be at 0 and pi. And what happens, because it's periodic, it repeats, is it kind of breaks the sine curve into very technical math terms here, kids. What I like to think of as baby parabolas. So what I'm going to do to take this sine curve and make it cosecant is I use the same point here and I flip it to an up parabola. That transforms it into cosecant. Another baby parabola here. This one's going to flip and open down. So what I drew in red is technically the cosecant graph. So I don't stand up here and be like, oh, asymptote. I just know I got to break apart my baby parabolas, is what I like to call them, and I flip them. That transforms it to cosecant. Now I need a second period. So let's do the second. Can I skip the second period for the sake of time?
Yes.
Okay. All right, throw some numbers on. Again, let me see. We might, let's skip B. No, let's skip B. And I'm going to do C because C is harder because you have more shifting on it. So let's do C. Good try, Avery, good try. So think about it if it said sine. So amplitude, absolute value of A. Period, 2 pi over B. B is 2, 2 pi over 2. Increments, period over 4. This has a phase shift, not just because there's a line on it this time, but we're adding or subtracting something to x. You should be able to take that expression and set it to 0 and solve it in your head. X equals pi over 2. We're going to shift to the right. And we have a center line shift. Center line's moving up to where? 1. So mark it out like I did the last time. Anything you would for sine, and we're going to break apart our little baby parabolas. For the sake of time, I'm only doing 1 period. Okay. Draw your new center line on first, which is at 1. From your new center line at 1, I'm going to count out the amplitude. So I'm going to go up 1 more, so I'll have a height of 2, and I'll bottom out at 0. So 1 up, 1 down from the center line. I like to put my increments and everything on my new center line. It just draws my eye to it. Now, phase shift though. First thing you got to mark is pi over 2. And from there, I need 1, 2, 3, 4 more. And we're scaling, oh fun, by 1/4 pi. Okay. What's a half plus a quarter? 3/4. Plus a quarter. Plus a quarter. Plus a quarter. So from the red 1/2, the end green 1.5, we are covering a pi. Now I'm going to draw, of course, the sine curve first. Now here's my new starting point at the phase shift. Catch it, your lead coefficient's negative. So not hill, valley, valley, hill. So this is the sine part. Now, of course, there's asymptotes. It's really a fraction, blah, blah, blah. We're bored. We're just going to zero in on our little baby parabolas, break them apart, and flip them. So my first asymptote's here at pi over 2. Then at pi, break my little baby parabola and flip him. And then same thing here. So that would be 1 period. You would need to draw a second, of course. But let's do secant. So, but really, I mean, what am I going to do for secant? I'm going to draw cosine, and I'm going to do the same thing. I'm going to break apart the baby parabolas and flip them. Okay, but of course we're going to start with cosine. So think about everything you know for cosine is true. I'm just going to put all cosine attributes are true. Has all the same thing. Period 2 pi over b. Amplitude, absolute value, a. Increments of period over 4. Okay, you're sick of that. There are also vertical asymptotes because it is technically a fraction. And of course that's going to happen when cos is 0. 0 under the line undefined. And of course cosine is 0 at the top and bottom. But again, plus 90 minus 90. Again, I don't even get into a frenzy over my asymptotes on these guys, because again, I'm breaking apart the parabolas basically and flipping them. But the only thing that's different, I'm going to start by drawing out cosine. Bless you. So, I'm just looking at this. What do we got? 2? Yeah, we can do it. Let's do these last 2. So I'm going to, of course, start with everything I know that's true for cosine. I'm going to draw cosine blue. So, of course, amplitude, absolute value of A, 2 pi over B, you know the drill. So marking everything for cosine, amplitude 1, 1, 2, 3, 4. I'll just give you a second to catch up here. Now, when I draw cosine, remember, I'm going to draw it dashed because it's like my template, and I'm going to convert it. Now, remember, cosine starts where? At A, and our A is 1. So, again, I have some kids that just put the dots on the points like that and can transform it. I'm going to, of course, dash it on. I'm going to try to make that look pretty. So we have our one big valley over here. Now, so of course I can see obviously this little baby parabola in the middle. I'm going to start there. I'm going to split it. So I'm going to have an asymptote at pi over 2 and 3 pi over 2. That's the easy piece. So what I'm drawing in red, of course, is secant. Now, there are 2 other pieces to this. Because cosine, you know, you just have the one big valley. You kind of end on a half curve, so to speak. So you have half of a bottom right parabola. So I'm going to flip it to an upright parabola. And then you have this little half on the other side that you end on. Again, bottom left side, so I need a top left. So what I drew in red is 1 period of secant. All right, let's do the last graph, but let's do 2 full periods on it. We've got time, let's do it. You sound excited. Come on now, come on. Yeah, come on. All right, so again, think of everything if you had cosine. Do I care if you actually rewrite it with cosine in it? No, I just like to for your notes. Okay. So amplitude, of course, absolute value of A. A is 2, the lead coefficient. Period, 2 pi over, what's ours? 2 pi over,
4.
so pi over 2. Increments. What's the period divided by 4? You're welcome. That was my sarcasm. Phase shift. There is none. There's nothing specifically added to x. There's no parentheses. You can write none or cross it up. I don't care. Center line. 2. We have the vertical shift up to 2. So we're going to draw cos first. Now, remember, new center line of 2, so I'm going to draw that on first. There's my new center line. From your center line, we're going to go up 2, down 2. So I'm going to have a max height of 4 and a bottom of 0. I'm kind of glad there's no phase shift, okay? So 4 increments, of course, and we're scaling. This is fun, pi over 8. That's not awful. And again, I don't care if you put the increments on the new center line or your x-axis. I just do the center line because it draws my eye to that's kind of the middle where I'm drawing. Pi, what's an eighth plus an eighth? Fourth, 3/8, and then 4/8. So I'm going to, of course, mark out the cosine. Cosine starts at A. Our A is 2, but we're 2 up from the new center line. So we're starting way up here at 4. Center line. Down 2 more. So I'm going to dash this on. Now, before I convert it into secant, because we are going to do the 2 full periods, I'm going to go ahead and keep going on my cosine and get the second period mapped out. And again, you can see I stepped over here to the left because I'm just going to quick and easy do the negatives. So I'm just going to repeat that same curve. I'm just going to carry on here for my second period of cosine. Okay. Now, remember, this has vertical asymptotes because secant's technically a fraction, 1 over cos. So I'm like, oh, where's cosine 0? Goes to 0. Again, I don't get crazy about that. You can if you want, but I just think about splitting up these little baby parabolas. Clearly, here's this guy. So what I'm drawing in red is technically going to be the secant. This looks like one of those like modern paintings, like they charge you a lot of money on, that looks like a 5-year-old could have splattered paint. Okay. Whew, gosh, here we go. I'm going to start at the left and go all the way to the right. So my first little piece of cosine is this end one, a bottom right, so a top right. Ooh, that's kind of tight there. Baby parabola here, flip it. One right in the middle. Ooh boy, kind of out of room, but I'm going to sneak him in there. Another full baby parabola, and then your half piece on the edge. So cosine, secant, you could usually end on those half pieces because you just have that one big valley, so you have the half sides on it. Elliot.
Well, can't you just think of the place where cosine is equal to 0 as the place where the cosine curve meets the center line? So
Always.
it's the same place where like the curve switches around.
Yep, always. Yep. So that's why I really emphasize sine and cosine a lot, because really it's not that much extra work to do secant and cosecant. Yay, graphs. How much do you like?